Did you know these amazing space facts floating out there in the cosmos? It turns out the fundamental rules governing tiny particles, what we call quantum field theory, don't actually force the universe to last forever. The basic constants of nature, like the speed of light, seem steady right now, but physics offers no eternal guarantee for their stability. This leads to a wild idea. Reality itself might be completely contingent on things, staying stable for a little while longer. Essentially, the universe is operating today only because its underlying mechanics haven't broken down yet. To wrap your head around this, just picture the entire cosmos as a massive, intricate board game. Currently, the game's rules are consistent day after day, which is why everything feels reliably solid and normal to us. However, scientists suggest these foundational laws are absolutely not set in permanent stone or unbreakable crystal. They carry no inherent promise that they absolutely must remain precisely the same way forever. So, the universe is functioning perfectly fine at this very moment, not because change is impossible, but because so far, nothing has actually gone wrong. It is like a complex, long-running machine that continues to hum along simply because, for the time being, every piece is still perfectly aligned. Astrophysics has long revealed that space-time itself, the very fabric of our universe, can stretch, curve, and even tear under massive influences. However, when we dive down to the incredibly minute realms described by quantum theory, the picture changes dramatically, suggesting space-time might actually be frothing. This concept implies that the smooth, predictable universe we observe every day is really just an averaged-out illusion, masking intense, violent chaos happening at the fundamental level. To be precise, astrophysics explains that space-time is the unified concept of space and time combined, and it demonstrably has the capacity to stretch and curve in response to mass. This bending phenomenon, which we know as gravity, occurs because massive objects, such as planets and stars, exert a profound pull, distorting space-time, much like a bowling ball deforming a stretched rubber sheet. Now, quantum theory urges us to look even deeper, focusing our attention on unbelievably small distances known as the Planck scale, where our classical understanding breaks down completely. At this fundamental resolution, scientists hypothesize that space-time loses its continuous nature and ceases to be smooth. Instead, they suggest it behaves like what is termed quantum foam, a seething sea filled with microscopic bubbles, constantly forming and vanishing in an instant. These ephemeral disturbances are formally known as quantum fluctuations, arising from the core principle of quantum mechanics, that nothing, not even the vacuum, is ever truly static or completely still. This means that space-time itself is constantly undergoing tiny, energetic wiggles and momentary changes that defy our macroscopic perception. Ultimately, the seamless and tranquil universe that we readily experience is simply the macroscopic result of all that microscopic chaos, averaging itself out over time and distance. It's a mind-bending thought. What appears to be a perfectly calm, quiet road on the surface could, upon close inspection, be revealed as a turbulent, stormy ocean of activity. It turns out that even the deepest, emptiest parts of space aren't as calm as we might think. According to modern physics research, this concept, rooted in quantum physics, suggests the vacuum is constantly buzzing with unseen activity. These fleeting energy shifts create what we call virtual particles, popping in and out of existence for mere moments. When scientists talk about the true empty space, they are technically referring to the quantum vacuum. This vacuum state doesn't signify absolute nothingness, but rather an absence of large, stable matter, like atoms. The key to this strange behavior is a phenomenon scientists label as quantum fluctuations. These fluctuations allow for the spontaneous creation and immediate destruction of tiny virtual particles. Because they vanish almost instantly, these particles remain completely invisible to our standard observations. The fundamental reason this activity occurs is due to the famous uncertainty principle in physics. This principle essentially forbids the universe, even a vacuum, from ever achieving a state of absolute rest or perfect zero energy. Consequently, we must discard the comforting idea that empty space is inherently calm or peaceful. Instead, this foundational fabric of reality is constantly active, restless, and fundamentally unpredictable. Understanding this instability helps redefine our entire perception of what the cosmos fundamentally is. Number 4. New astrophysical models are now suggesting that some of the universe's very largest stars can bypass the dramatic explosion phase and vanish without a trace. Remember that stars are fundamentally gigantic, glowing orbs composed primarily of hot hydrogen gas, shining brightly due to constant nuclear reactions happening deep inside them. Typically, when a truly massive star runs out of fuel, it results in a spectacular supernova, which is an immense energetic outburst of light seen across the cosmos. However, the discovery reveals that the most massive stars can undergo a direct gravitational collapse, straight into a black hole, without that spectacular supernova event. This means the entirety of that colossal star simply ceases to exist in the visible universe, replaced by an infinitely dense, yet completely invisible object called a black hole. It is like the cosmic equivalent of a massive stage light being extinguished instantly, where the star vanishes quietly, leaving no final, glorious visual warning whatsoever. When you look up at the dark night sky, you aren't seeing the universe as it exists, right this very second. In fact, a staggering number of the stars you see have already completed their life cycles. The light hitting your eyes tonight departed its source long before you or your ancestors were even a concept. This means you are observing messages from celestial objects that might not even exist anymore. Every single twinkle represents light that has journeyed an incredibly vast distance across interstellar space to reach our planet. Since light travels at a finite, though fast, speed, this journey naturally takes a significant amount of time to complete. For the most distant celestial bodies, that transit time can be measured in the millions or even billions of years. Consequently, what you are witnessing is an honest-to-goodness historical record, not a live broadcast. A bright point in your vision could very well be the beautiful ghost of a star that has long since faded. That specific photon, however, is still tirelessly traveling through the void on its way toward us. Observing the galaxy is essentially the purest form of looking directly into the deep past. You are viewing a single, frozen moment of the cosmos from an epoch predating human civilization entirely. This humbling realization puts our fleeting existence into a truly humbling perspective. It's a concept that brushes against the edge of pure cosmic horror, seeing things that are fundamentally gone. So next time you step outside on a clear night, reflect on this ancient light and try to sleep well after considering. Thank you so much for joining us on this incredible deep space voyage today. If you enjoyed exploring the mysteries of the universe, please show your support with a quick like. Sharing this content helps bring these amazing cosmic visuals to more space fans everywhere. Don't forget to hit that subscribe button so you are ready for our next launch.